All right, I'm going to start looking at some two-step equations. We've already looked at a lot of one-step stuff with addition, subtraction, multiplication, division, okay? Going to start delving into some two-step stuff today. Guys, the first thing you need to be able to do, in my opinion, is one, be able to visually start kind of seeing the difference between a one-step and a two-step equation. So if you take a look here at this first equation, this, something like this should look fairly familiar. This is kind of what we were dealing with the other day for a couple classes. X minus 4 equals 2, okay? What would you be solving for here? You'd be solving for X. What's the one thing that you have to get rid of here to get X by itself? And how would you get rid of it?
I found this on the web.
You would add it, right? You would add it to both sides, okay? And then, what is the number in front of that X? 1. It's a positive 1. And that's what we need. When we solve these equations, those equations, whatever variable is being used, that variable needs a positive 1 in front of it. And if we look here, that X already has a positive 1 in front of it. So we know that when we get that X by itself, we are solved. Okay? Now, if you take a look at that second equation, what's sitting in front of that X? 2. There's a 2 sitting there. Okay? And, this is something that you need to kind of visually be able to start to recognize as we look at the second equation, 2x plus 3 equals 7, and we say, okay, I'm still solving for x here, but if I look at this, we've got this 2 setting in front of this x. That x does not have a positive 1 in front of it. So we still need to get 2x by itself first. What would we have to get rid of to get 2x by itself? 7. What's on the left side with the 2x? Was it?
3.
A 3. So we're going to have to get rid of that 3. How would you get rid of it? You would subtract it, okay? But then you're still going to have to get rid of something else with that x. That's hence the second step, hence two-step equations, okay? But if we just look at these equations, you need to be able to start to visually see how these are starting to look different. Because every problem, any equation that you encounter, you should kind of visually inspect anyway. And we should look at it to kind of formulate a little bit of a plan to start to solve it. Okay? Is everybody okay with that? You kind of see a little bit of the difference here?
There's a 2 in front of that.
Correct. The first equation, there's an understood 1 in front of that x, and that is great. The second equation, there's a 2 setting in front of that x. That's the second step. You're going to have to get rid of whatever's in front of that x. Okay? So again, a lot of this is going to be visual recognition so that you can start to formulate a plan for how you're going to solve these equations. Okay? So I really like to emphasize the visual aspect of this. All right? Let's look at the next one here. Okay? First equation. X over 4 equals 6. What are we going to be solving for? X. What's the only other thing on the left side with that x?
1.
The 4. 4, right? What's going on between the x and the 4? What? There you go. What does that bar mean right there? Division. So when we look at that, we look at this equation and we see x divided by 4 equals 6. That x has a positive 1 in front of it, correct? Okay. What's the only thing you would need to get rid of to get the x by itself? The 4. And how would you get rid of it? Exactly. You would multiply it. So you'd multiply both sides by 4, one step, and we're done. Okay? If you take a look at the second equation, draw my line there. I think it's pretty obvious that you see x over 5, right? What else is on the left side with that x over 5? There's a 1 there. Okay? So again, that left side, there is some division going on, and there's also some addition going on. Which one of those would you probably get rid of first? Well, and I will say there's not really a right or a wrong to this because you could do it a couple different ways, but I would generally say that solving equations, you are more times than not going to be adding and subtracting something first before you multiply or divide. So with that second equation, I would probably say more times than not you would get rid of the 1 first. How would you get rid of that 1? You do what? You would subtract it. You would subtract the 1 from both sides, and then how would you get rid of the 5? You'd multiply, exactly, because you're starting to see division there, okay? So, but there's 2 steps there. There's a subtraction step, step number 1, and then there's going to be a multiplication step, which would be step number 2, hence 2-step equation.
Don't you also multiply the thing on the other side, the equal sign?
You would. Yeah, you would subtract 1 from both sides, and then you would have to multiply both sides by 5. But again, I really think the visual aspect is important, that you're able to look at a couple of equations like this and start to see where one of them is going to be a 1-step solve and the other one is going to be a 2-step solve. And it just comes with experience and looking at these things, all right? Is everybody okay with that? Any questions thus far? Okay. All right, so let's solve some, okay? Let's start here on the left side, okay? 3x minus 2 equals 7. And just like we discussed with 1-step equations, I'm still going to draw that line through my equal sign. That equal sign is what determines left side and right side, okay? How many steps is it going to take us to solve this? It's going to take us 2, right? Okay, what are we solving for? We're going to solve for x, okay? We're still solving for the variable x, but what's setting in front of that x this time?
3.
There's a 3 set in front of it, okay? So again, visual recognition. We've got 3 times x minus 2 equals 7. What do you think we will probably get rid of first? The 2. And how? Going to add it. I agree, because that 2 is being subtracted. That is 3x minus 2. So let's go ahead and let's add 2 to both sides. We're going to balance the equation. Negative 2 plus 2, gone. You are left with 3x. 7 plus 2 is 9. Okay? Now, that term on the left side, that 3x, that's what I refer to as the variable term. That is the term that contains the variable that we are solving for. Okay? So I have isolated my variable term on the left side. Okay? I'm still trying to solve for x. What is still setting in front of x? 3. How am I going to get rid of that 3? Okay, excellent. We are going to divide both sides by 3 because that is 3 times x. And we had mentioned that the other day, that multiplication is that operation that necessarily doesn't need a symbol. Everything else does. Addition, subtraction, division, they've got to have some kind of a symbol. But multiplication, that is 3 times x. So we are going to divide both sides by 3. 3 divided by 3 on the left side is a positive 1. There's that positive 1x that we need. Guys, what's 9 divided by 3? 3. Boom. Okay? We always like it when the answer comes out nice and neat like that. They don't always do that, but when they do, it's pretty nice. Okay? Is everybody okay with that? Okay? 2-step solve. You will generally add or subtract something first and then multiply or divide to solve generally. Okay? That's not always the case, but more times than not, that's what you can count on. Okay. Let's go over here to the right. I'm going to draw my line. Make sure that we understand left side, right side here. What are we solving for? Going to solve for x. Now, let me ask you this question. What is setting directly in front of x this time? A negative 2. Okay? And guys, remember, I think we mentioned this. That minus sign, when you read that equation, 4 minus 2x equals negative 6, that minus sign can be interpreted as a negative sign. That 2 technically is negative. So when we look at the variable term is negative 2x. We are trying to solve for x. There is a negative 2 setting in front of it. Okay? Be careful about that. Now, what am I probably going to get rid of first in order to get 2x, negative 2x by itself? Okay, the positive 4. And how are we going to do that? Subtract 4. Check it out. Let's subtract 4 from both sides. Those 4s will go away. Please, please, please make sure that when you get rid of those 4s on the left side, that you bring down the negative with the 2x. There's a lot of students that will overlook that because they interpret that as a minus sign. Thank you. There you go. Thank you. Hurry. Okay. On the right side, what is negative 6 minus 4? Negative 10. Same sign, keep the sign, add the numbers. Negative 6 minus 4 is negative 10.
Can we use the bathroom?
Yes, sir.
Of course.
Okay. How are we going to get rid of the negative 2? Divide by negative 2. Let's divide both sides by negative 2 because a negative divided by a negative is going to be a positive. There's that positive 1x. Negative 10 divided by negative 2.
5.
Positive?
Yes.
Positive.
Good. Say it with confidence. Positive 5. And again, we like it when the answers work out nice and neat. Got a nice integer answer. Okay? But again, 2-step equation, visual recognition, okay? Watch my signs here, know what we're solving for. Any questions on these two before we go to the next one? Okie dokie. All right. Got a couple here. A little variation. We're still looking at 2-steppers. Okay. Here on the left, there's my line. I'm going to divide that into left side, right side. On the left side, what are you probably going to get rid of first?
6.
Oh, the left side 6.
Now, what are we solving for? Solving for x, okay? What's going on between the x and the 4? They are being divided. Is there anything else on the right side with the x and the 4?
A 2.
There's a 2 that's being added, right? Okay, so on that right side, the variable term, there's that terminology again. The variable term is x over 4. Whatever term contains my variable, that's what I want to try to isolate first. So the x over 4, we're going to need to get that by itself on the right side first. Well, what else is on the right side with that? 2. How are we going to get rid of positive 2? Thank you. Subtract 2 from both sides. Subtract it from the right, subtract it from the left. Guys, and again, it's kind of that general anticipation. More times than not, you're going to probably add or subtract something first before we do anything else, generally. On the right side, 2 minus 2 goes away. That's what we wanted to happen. Left side, 6 minus 2 is positive 4. Right side, we have x over 4. We have isolated the variable term. Okay? Is everybody okay with that? All right. Now, we can look at isolating that x, and we already determined, we said, hey, there is division going on between x and 4. Well, how do we undo division? Multiplication. So if x is being divided by 4, what do you think we're going to do to both sides? Multiply by 4. Multiply by 4. Multiply by 4. On the right side, the 4's gone. You are left with the positive 1x. That's what we wanted. We got it. On the left side, 4 times 4? 16. Boom. And I think I said this the other day, and I know that probably hardly any of us would ever do it, but remember, if you get an answer, you can take that answer of 16 and plug it back into the original equation to see if it works. 16 divided by 4 is 4. 4 plus 2 is 6. That makes a true statement. That answer works, okay? So that's always an option for you. Multiple choice test. You can always take the answer, start plugging them into equations. Okay, I mean, that's a valid way of checking things. Okay, is everybody okay with that one? Okay. All right. Draw my line on the right side there. Let's determine right and left. What are we probably going to get rid of first, that equation on the right? And how? Add 1. Probably need to get rid of this negative 1. My variable term is x over 9, so let's get rid of this negative 1 by adding 1 to both sides. Thank you. Negative 1 plus 1, gone. Negative 1 plus 1, gone. X over 9 equals, okay, negative 2 plus 1, negative 1. Watch your signs. Those stinking integers. They just never go away. You're going to always be dealing with integer numbers. So here's what we've got. Variable term is isolated. X over 9 equals now negative 1. How do we get rid of the 9? Multiply it. There you go. Again, visual recognition tells us, hey, x is being divided by 9. Let's undo that with some multiplication. Let's multiply both sides by 9. Left side, 9 and 9, gone. Left with a single x. That's what we want. Negative 1 times 9 is negative 9. Nice. Okay. Okay, questions on either of these two? I got one more. Two-step equations, guys. Again, these are routine plays. We see a two-step equation. We need to be able to solve it pretty efficiently, fairly quickly, okay? And again, just comes with one, visual recognition, and then just understanding the steps. You know, generally going to add or subtract first, then probably multiply or divide to solve. Okay, let's take a look at this one. 4x minus 3 equals 3. There we go. Left side, right side. What are we probably getting rid of first? Negative 3. Okay, I agree. You guys are starting to see it. My variable term is 4x. How do we get rid of negative 3? Thank you. Add 3 to both sides. And 3 plus 3 is what?
28.
Say again.
28.
Okay, thank you. Okay. Now, how are we going to solve this? What's the final step to solve? Divide by? 4. Okay. Now, I will tell you, we're going to divide both sides by 4. Some students will stop right here because they realize, can you divide 6 by 4 evenly?
Nope.
You can't. And some students will stop and they'll go, ooh, wait a minute. This isn't going to divide evenly. What do I do? Guys, when you're solving these equations, go ahead and perform the steps that need to be performed. We need to do a division step here. We need to divide both sides by 4. Let's do that. We're going to create a fraction, which I know kind of stinks. Here's our x. We create a fraction, 6 over 4. And that's okay. Now, can you reduce this fraction anymore? Can we reduce 6 and 4? Is there a number we can divide both 6 and 4 by? Okay, so let's divide both of these by 2. And what would that be, 3 over 2?
Yep.
So it's okay if our answer doesn't come out to be a nice, neat integer. But if you get in that situation where you go do the division step and you're like, ooh, wait a minute, that doesn't work real well. Guys, create a fraction. It's okay. Just make sure that the fraction is reduced to lowest terms. In this case, 3 over 2, and we're good. Okay? Question?
That's the answer.
That is it. X equals 3 over 2. It's not the nicest answer, but I'm just telling you, sometimes you're going to have fractional answers, and that's okay. But I will have some students, they will stop at that division step, and they'll go, wait a minute, this isn't going to work. Okay? Any other questions about that one? Okay, let me show you one more here. Because I just thought of something else. Let's do this. Let's go 2x plus 2 equals 2. We'll just use 2's here. It's fine. Do what? 2x.
Because once you subtract it,
All right.
on both sides,
What are we probably going to do first?
get rid of this.
Minus 2.
Okay, subtract 2 from both sides. So 2x equals, what's 2 minus 2?
2, 0.
0.
Well, yeah, now you know we can put 0 because it's still a number.
That's right. Now, again, just like the last problem, there are a lot of students that will get right here, and for some reason, that 0 setting there kind of bothers some people. Because it's like, how do you solve for x here? How do we get rid of the 2?
Divide.
We're going to divide, okay? But I'm just telling you, that 0 bugs some people. They'll see that 0 and they'll go, ooh, wait a minute, what do I do? Guys, go ahead, perform the division step. Divide both sides by 2. Get the x. What is 0 divided by 2? What's 0 divided by anything? 0. Guys, an answer of 0 is okay. But again, I'm just telling you, that bugs some people. Okay? Whenever they get those fractions, they see 0 set, and it's kind of like, ooh, wait a minute. Guys, perform the division step. 0 divided by anything is going to be 0. 0 is a valid answer. Okay? All right? Questions?